Hello, how's it going? So in this video, this will be linked lists Ada, the thrilling conclusion. I'm going to adjust my linked list so that it can keep elements in sorted order. And I'm also going to render or draw the linked list in STL. So there are a few stages. For one thing, I'm going to just adjust this project a little bit. So I'll make a new folder. I just want to organize my code basically. So let's say at a future point, I'm working on my project and I want to have a bunch of different custom data structures. What I can do is just organize this into a folder, and then there's probably much better ways to do this, but this is just a band-aid for now, is I'm just going to go to my project specification and tell it to look in the data structures folder. So I can run this and verify that it's working, and yes it is. Okay, and now I'm going to, let's say again I'm working on my project and I might want to define a whole bunch of custom data types. So for my example here, I'm just going to have a single data type. It's going to be a person. It will have an ID integer, which will just be used for sorting people and keeping them in some sort of order. And it will have a name, which is just like this. It's an example of holding some custom data. So for the name, I'm going to use Ada's unbounded strings. And I'm just going to put a really simple body in for now, because I just don't like that it's not really auto-completing. Maybe I'll just continue with it for now. So, like I said, I'm going to define a custom data type. Go. And there's two methods that I'm going to define. I'm going to have getters for both of these basically. Now the reason for this is for my interface I'm going to need to have some sort of general function for any custom data type that I make, which returns an integer which can be used to sort them. If I override this function and I just make it return 0 every time or something, then we'll have no sorting. Otherwise, yeah, I can implement sorting. And then for my print function that I made in my main, it will be helpful to have a general sort of string builder function. As for the body, really the only stuff I need to define is these getters. And these will be quite simple. Okay, just simple string concatenation. This will just make, yeah, good string representation. Okay, why are you complaining? In case anyone's wondering, the reason that I'm using a terminal to run my elir commands is just that VS Code is trying to, for some reason, overwrite the environment variable that was set. So if I go and like run this way, I wish this worked. But it says something, and maybe someone can help me with this, but it says something along the lines of, there's this environment variable, which has been defined to basically my nat toolchain, but for some reason the VS Code extension is trying to override it with some snap location, which that's great. And I've looked around in the extension and I have no idea how to overwrite this. I don't know. It's weird. It's very weird. But, okay. I'm going to need to refactor this a little bit. So I've got types, and now this int list I'm going to change. I'm going to change this to a person list. Maybe I should change. I changed my mind. I'm going to have a look at the data structure first before I use it. So here I've defined my general parameter. I'm also going to define some sort of generic function. There's some function, it's named key. It takes an item, which is an instance of my generic type, and it returns. Nothing else here has to change. But then I can go in to the insert function and I can use that key function that has been defined. So I'm just going to change some variables here. I've got the new node which is coming in, and then I'm also going to keep track of previous node and the current node that I'm looking at. And these will be, so I've got a few more cases to consider. In the case where I've got an empty list, yeah, no problem, just directly insert. In the case where I've got at least one element, there are still two more subcases. One is where I'm replacing the head itself, and then the other case is where I need to look through the list and insert somewhere else inside the list. Because if we replace the head, we don't have a previous node to link to this node, whereas if we insert somewhere else in the list, then we're dealing with the previous node. So anyway, my cases here are the case where we replace the head, and the way we detect that is we get the key for the data in head, and if that is bigger than the key of our new node. And then in this case, the new node becomes the head, so it needs to point to the original head, and then, yeah, we'll just overwrite. Cool, okay. So we've done that, and insert is over in this case. Now, in the next case, we'll need to actually search through the linked list. Okay, so we'll say the previous node, the last node that we searched, is the head. And the next node that we're going to search will be whatever came after the head. Now for the search, we'll keep going so long as the current node is not null. And then our condition for stopping the search is, again, when we look at the current node and its key value is bigger than the incoming thing. And we could look here and say, well, look, we're evaluating this function a bunch of times. Could we evaluate it once, store it in a variable, and just query that variable? Answer is absolutely. There's no particular reason to do it this way. I just wanted to do it this way. Felt it was a little more readable. Yeah. So, previous none, that's going to be a problem. Okay, well, in this case, we're going to continue the search. So the previous node will be the node that we just searched, and then the node that we just searched is going to be the value after, or the node after. But then when we get to this point, we've basically found an appropriate insertion point. And so we want to insert between previous and next. So we'll get our previous node, and it will point to the incoming node, and then the incoming node will point to current node, which could be null. That's perfectly fine. Cool, so that's our insertion, sorted insert. It's pretty good. So as for actually using this stuff, I'll go back, and yeah, like I said, we've got this person list. Now, as for the key, I'm going to get, actually going to use, actually, no, I am. I'm talking to myself. So we're going to use the person record for the type, and then that key function will point to the person function. Okay. I was going to organize this a little bit. Cool. So now I just need to go down and, yeah, I can change the print function for sure. So I'm just going to use that image function so that now the job of representing this as a formatted string is handed over to the data structure to the data itself. And I hope that is correct, but I think it should be fine. Now down to these inserts. So of course I'm going to need to change all of these. So now I will go ahead and construct a person for their key. I'll give that. And I'm just going to quickly go up the top. Okay, I think this is fine, but the best way to find out is to actually run it. Okay, cool. So we can see here that although we've inserted, in this order, the elements are being maintained in order of their keys. So yeah, that's pretty cool. But now for part 2, which is the other cool thing we can do, which is visually draw this list. So I'll just get this stuff out of the way, and I'm going to deal with this render function. So for this render function, I'm going to, well, first up, First up, I'm going to need a specific data type, which is, it's an SDLC data type, integer. Now the deal is with some of these functions, they can work perfectly fine with Ada numbers, that's fine, but then with some of the functions they need to be C functions, and I'm just working with the rules of the game basically, but I'm going to define a few other things which will be useful. This will be the width in pixels for every full node representation. So a node will be a box in which the data is displayed, and then an arrow which points to the next node. What I'm going to do is I'm going to loop along, and I'll have some offset that I increment for every step of the loop. Okay, this is a pretty good start. So I'm just going to draw a box for every element. So the first thing I'll do is I'll clear the screen just like we've got here, and then I'll set the draw color to like a green, and I'll step through and draw a bunch of boxes. So first up, for every step I'll shift a little to the right, and then I'll draw. So I'll get my renderer, tell it to draw. I'm going to draw a rectangle. Okay, let's give that a go. Whoops. What am I thinking? Okay, yeah, so when we go to render, it's going to be my list. There we go. Cool. So we've got, 4 nodes, 4 boxes. Now I'll add arrows. Okay, so this turns out pretty nicely. So the first thing I'll do is I'll draw the arrow segment, just a straight line going across. So I'll get my renderer, drawer, and then I'll draw a line, and I can do this by constructing a line segment, and then the line segment, as we can see here, has got a start and a finish, and these are both STL coordinates. So I'll go STL. And then I'll draw the top and the bottom of the arrow. So for both of these cases, this bit here will be the end point of the arrow. Anyway, it's not super exciting. I'm just twiddling some numbers here. Cool, yeah, so these second points, these finish points for the line segments, line up with the rightmost end of the arrow, and then the start is pulling back a little bit, back and down basically. And I don't know why my laptop is trying to take off, but here we go, we've got some arrows. So now the last part is I want to put some text inside these boxes to display what's actually in them to verify that this is working. Now to do this, To do this, I'm going to need a new package, which is SDL-TTF, true type fonts. So this is another binding made by Lucretia. We can see here we've got all of these like mixer for audio, image, all this stuff. And the one I'm into is TTF. Why does it say SDL mixer? Well, I don't know. Anyway, so it's this line here again. This GitHub repo address, we can copy that and then pop back in, paste that. And I'm pretty sure I've installed this ahead of time, but it goes ahead and says, hey, we're going to pull this stuff in, is that fine? Yep, no problem. So we should now have access to TTF. Now, TTF is based around files. So if you look in the GitHub repo, there will be this font.ttf file, but it's just here. You can swap it out with whichever one you want. I just grabbed the first thing I could find. Okay, so this font.ttf, this is the one that I'm going to use. So let's pop in here, and I've already declared that I'm using TTF, so that's fine. But what I want is SDL TTF's makers. And by the way, just a side note, you can always sort of pop in and view info for anything we want. This is a really good thing I found so far about using this binding and Ada in general, is you can always pop into a library and see sort of exactly what is being expected for each of these data types, which I think is pretty cool. But yeah, so I've got this TTF's makers, and if I go down to my variables for this program, in addition to all of this, I'm going to have a font, and this font, its data type will be SDL TTF's. I may need to reload this project. There we go. I love how it just doesn't recognize anything. That's great. Okay, but now it's recognizing it, and we can sort of click in, and yep, it's fonts. Okay, that's something. Right, so in my program, before I go to render, I'm going to need to create some stuff. So up here, I initialize SDL. I'm also going to initialize the font module. I don't need any flags here. And then down here, I create my objects. I'm also going to create my font. Okay, so there's a few things here. Yeah, I'm going to use this simpler version. So I've got my font that I'm going to create. Then I have my file name, which again will be font.ttf. And then I've got my point size. So my point size, I'm just going to experiment with this. We'll see how it goes. Now, as for actually rendering, I'm going to add in some other modules. I don't know if this is necessarily the only way to do it. It may not be, but I'm going to render the font to a surface, and then I'm going to convert that surface to a texture. And then that texture can be copied to the screen, basically. Okay, so I'll go down to my render function, and I'll add a few more things. I'm going to have a text surface, and then a text. Okay, so first thing I'm going to need to do is basically render the font to the surface. So I'll get text surface. Yeah, render solid. So I'll have the font that I'm rendering, the text that I'm going to render, which will be the image of the node, and then, yeah, the color that I'm going to render, which I'll make it red, a bright red. So having that surface, I'm then going to use that surface to create a texture. Okay, so I'll have the texture that we're making, the renderer, and then the surface, which will be converted to a texture. And having done that, I'll then, yeah, copy that to the screen. So we'll put in the renderer, which will be doing the copying, the texture, which we're going to be copying over, and then it says here the rectangle, which will be okay. So fingers crossed. I know that last bit is a little bit like, how do you do? But this is basically constructing a rectangle, and it says here, if we hover over that 2 parameter is a rectangle, and it's a float rectangle, which is why I've put in floats for all the parameters. I think it's a little strange that this has to be a float rectangle, but there it is. Okay. Oh my goodness. This should be renderer, not render. Fingers crossed. Okay, that's a little messed up, but I think we can. Let me try. I think the pixelation might be caused by a small letter size. Does that make a difference? Does it matter? I really don't know. A little bit of a difference, but there we have it. The thrilling conclusion. So now our inserts are sorted, and we can render things properly, so we can verify that it looks good, even though it's really just an example of how to use STL. But yeah, there we have it. I understand this video might have been a little bit boring. There's a little bit of just saying very obvious things as I clunk through it, but I had fun. I definitely had fun making this. This code here is a little verbose, so if you check the GitHub repo, I've got a more better written one, which is more readable. But yeah, all the best for now, and I will see you again soon. Bye.